All right, guys, in this video, we're going to be looking at example 11. In example 11, we're asked to determine if each geometric series converges or diverges. Remember, this is important because if it converges, it can be used as an infinite series because it's going to be approaching a single value. If it diverges, we can't use the infinite series. How do we do that? We figure out if the common ratio, R, is between -1 and +1. So we need to find our common ratio. To find our common ratio, we're going to take our second term, in this case, -2/3, -2/3, and we're going to divide by our first term, divided by 2. And we could have chosen our third term divided by our second term, fourth term divided by our third term, but we're going to keep it simple and always use the second term divided by the first term. So we'll come over here to Desmos. We're going to plug it in. I'm going to show you how to do what I just did there. So when I have a fraction, I'm going to use those parentheses and I'll put in here -2 divided by 3. -2 divided by 3, and then divided by 2. And you'll see that what that does is it puts the -2/3 in the numerator, which is what I want, and the 2 in the denominator. If I don't do this, then it's going to be 2 divided by 3/2, which will give me the wrong number. So make sure you use those parentheses when you have fractions. Anyways, we got this -0.33. We need this in a fraction, so we're going to press that fraction bar here over in the blue. And we end up with -1/3. So this is going to be equal to -1/3. That is a number between -1 and +1. It's one of those fractions that's a little bit greater than -1. And so this tells me that this series converges. The series converges. Okay. So let's look at part B. Again, we've got this series, this geometric series, or this geometric sequence, I should say. We're going to take our second term. So in this case, R equals 12 divided by that first term, -4. And I don't need Desmos for this. If you want to use Desmos, you can. But 12 divided by -4 is -3. -3 is less than -1, so it's not in between -1 and +1. So I can say that this series diverges. And that tells me I cannot use my infinite series formula on this one because it's just going to continue to get larger and larger or smaller and smaller, but it won't end with that. So here are your triads. So go ahead and give those a shot. Remember, if you're using fractions, to use those parentheses to make sure they get in the right spot. And a couple problems for you to check out and see if they converge or diverge. So guys, if you have questions, please let me know. Otherwise, we can talk in class.